You now have an idea of how models are used in climate science, but models alone still don't enable us to get a glimpse into the future. That is why we need scenarios.
So let's return to our initial question. Why do different models produce such different predictions for temperature increase in the 21st century? To understand this, we need to look at how the models actually compute climate. For this purpose, we first grid the Earth as illustrated in the graphic. This grid has a typical mesh size of 100 by 100 kilometers on the horizontal plane and between 10 and several hundred meters in the vertical. The equations are solved for each of these grid cells. These computations require the largest computers available to us, for example, this computer at the German Climate Computing Center. But what should we do about processes that occur on such a small spatial scale that they are not captured by our grid? Such processes include, for example, turbulence and cloud formation. They occur on much smaller spatial scales and fall through the grid. In such cases, we must make assumptions that are plausible yet unprovable. Different models make different assumptions, and consequently they produce different results. Of course, we would rather reduce the number of these unprovable assumptions. We would rather use a much finer mesh. For example, to illustrate whether hurricanes, tropical cyclones, will occur more often and be more violent in the future, we would need a grid size of perhaps 10 by 10 kilometers in the horizontal plane, as opposed to the current 100 by 100 kilometers. We would need a grid that is 10 times as small. However, for this 10 times finer grid, we would need 2,000 times the computing power. This cannot be delivered by current computers, but will be possible in the next 20 years. And with this higher computing power, with a finer grid, we will be able to reduce model uncertainty. And therefore, returning to our original graphic, we will be able to reduce this spread of model uncertainty in the future. An uncertainty that we will not be able to reduce, even with our computer's greater power, is that of not knowing the choices mankind will make in the future. Will mankind opt for the path shown here in blue, to adopt effective climate change mitigation measures to reduce emissions and thus to limit the temperature increase? Or will mankind opt not to adopt climate change mitigation measures and allow both emissions and the temperatures to increase continuously? Will mankind make choices that would put us in the blue area or rather in the red? Or something in between? Or will mankind make no choices at all? But making no choice is a choice in itself, namely the choice to do nothing. And doing nothing in climate protection means that emissions will keep increasing toward the end of the 21st century. And thus the temperatures will increase further too.